Okay, let us see how to solve this exponential equation. It says 9 to the power of x plus 1 plus 3 to the power of x plus 2 minus 18 is equal to 0. So what to do? 9 to the power of x plus 1 is the same as 9 to the power of x times 9 to the power of 1 plus 3 to the power of x times 3 to the power of 2 minus 18 is equal to 0. So we can expand this, we can expand this in this way, because the exponential, remember there is a rule, if a to the power of m times a to the power of n, this is the same as a to the power of m plus n. So backward process will be this one. So I apply here the backward process, and 9 to the power of x and 3 to the power of x are not the same, but I can write 9 to the power of x as 3 to the power of x the whole squared. You know, 9 means 3 squared, so 3 squared the power of 3 the power of x the power of 2. I can write it because x times 2 will be 2x, so 9 by itself is 3 squared. I'm trying to rearrange and convert this one in this form. Then times 1 plus 3 the power of x times 9 minus 18 is equal to 0, because 3 square means 9. And then what's next? Let's replace 3 the power of x by any other variable. Let's say it y. So this means y squared times 9 plus y times 9 minus 18, which is equal to 0. So I can divide each of them by 9 to simplify. If I divide by 9, by 9, by 9, by 9, each of them cancel out, and then y squared plus y minus 2 is equal to 0 remain. So let's factorize this quadratic equation. When you when you try to factorize, product -2, sum the middle term, which is 1. These two numbers are 2 and -1. If you multiply, it will give you this result. Therefore this quadratic equation can be written as y plus 2 and y minus 1 is equal to 0. Then these two product is equal to 0 means y is equal to -2 or y is equal to 1. But now let's get it back. What's y? The y is the one which is found here, 3 to the power of x. So 3 to the power of x is equal to -2, or 3 to the power of x is equal to 1. But 3 to the power of x is equal to -2, this one is impossible, because the range of exponential function is positive real number. 3 to the power of x cannot be negative anyways. Whatever the number we plug here in place of x, it can't be negative, so this one cancel it. And 3 to the power of x is equal to 1 means it can be written 3 to the power of x is equal to 3 to the power of 0, because 1 means 3 to the power of 0, to make the base the same. So ignore the base, so x is equal to 0 will be the answer, the solution set. Okay, the second one, it is logarithmic. As you see, there are 3 logarithms, one to the right side, the 2 are to the left side, but it's connected by minus. Each of them have the same base 10, so I can write it logarithm of 3x squared plus 1. Okay, let me erase this one. Yeah, 3x squared plus 1 over 3 plus x. Okay, I can't write it over because it's minus. In case of minus, we have to make it divide. If it is plus, I will multiply. So is equal to logarithm of the right side, nothing will be changed, 3x minus 2 to the base 10. Now these two logarithms, they do have the same base, so ignore the logarithm now, and then equalize it. 3x squared plus 1 over 3 plus x is equal to 3x minus 1. This means over 1, I mean minus 2, sorry. This is over 1. So now I can apply cross multiplication. I will multiply this with this, the denominator. So 3x squared plus 1 remain, because 3x squared plus 1 times 1, which is equal to, I will multiply this one, 3 plus x times 3x minus 2. So expand this one, the bracket, remove it. So 3x squared plus 1 is equal to, when you multiply it, it will be 9x, then minus 6, plus 3x squared minus 2x it will be. Ignore now, 3x squared by 3x squared cancel out, and then what remain now? 9x minus 2x will be 7x minus 6 is equal to 1 to the left side, and then bring the 6 to the left side, so it will be added with 1. So 7 is equal to 7x if you divide both sides by 7, so x is equal to 1. After we finish everything, we have to check by plugging this number, does it give us true statement? Otherwise we have to exclude, unless we have to mention the domain at the beginning. But after we solve, we can plug the number. Let's bring 1 here in the first logarithm. If you plug 1 here, 3 times 1 square will be 3. 3 plus 1 is logarithm 4. It will be the second logarithm also 3 plus 1. It will be logarithm 4 minus logarithm 4 is equal to, if you plug 1 here, it will be 3 times 1 3. 3 minus 1, 3 minus 2 will be logarithm 1. logarithm 1 means it's 0, and here logarithm 4 minus logarithm 4 means it's the same as logarithm 4 over 4, which is 1 again. Logarithm 1 again it's 0. 0 is equal to 0. Always don't forget logarithm of 1 is 0, whatever the base. I mean for the defined base. For those all positive real numbers and different from 1, the base cannot be. So logarithm 1 is always which is 0. So that is true. So our solution set is x is equal to 1. The next one, it says express this logarithm, okay, as a single logarithm. There are two logarithms here expressed as a difference, so we have to make it a single logarithm. They do have the same base 10. So what I can do is logarithm of x minus logarithm of this 1 over 3 as the coefficient of the logarithm can be the exponent of the y here, so it will be y the power of 1 over 3, or y the power of 1 over 3 can be written, y the power of 1 over 3 it's the same as cube root of y. Therefore now the two logarithms are like separately having the same base, no coefficient, so we can write it logarithm of x over cube root of y. Because it's minus, we have to write it as a quotient. The base is 10 for both, so just one logarithm. It contains one logarithm. This is expression of two logarithms as a single logarithm. Thank you.